So finally here, for numbers 5 through 8, we have both numbers and variables underneath the square root or whatever radical symbols, and it can become a big mess, but it's very, very important that you go back and understand the big idea. So anytime the roots are the same, top and bottom, you get to combine the fractions. Now you get to combine the fraction under one radical. So we have 3n squared over 2n squared. This is where your ability to simplify fractions is going to be a big plus, because we see n squared over n squared, any number divided by itself is 1, so we get to cancel those and we get to replace them with 1. And so all we have now is the square root of 3 halves under the radical. But that can be written as the square root of 3 over the square root of 2. We can't simplify the square root of 3 or the square root of 2. We can't simplify the fraction anymore. So what are we left with? Well, there's a rule that says that you're not allowed to leave a square root in the denominator, and because it's an irrational number. So you're not allowed to leave irrational numbers in the denominator. And so what we call the process, what we're going to do here, is called rationalizing the denominator. So rationalize. We need to rationalize the denominator. And all that means is we need to get any square roots in the denominator out of the denominator. Well, how do we do that? Well, let's go over here. Take the square root of 3 over the square root of 2. Now we're going to multiply this fraction by 1. And what we have to do to identify what we have to multiply top and bottom by is just look at the denominator. What can we multiply this denominator by to make sure it is a perfect square? Well, the square root of 2 times the square root of 2 is 2. So if we multiply the denominator by the square root of 2, then the denominator will be rationalized. Okay? And then since we multiply the denominator by 2, we must multiply the numerator by 2. And again, we go back to what you learned in the last unit. Ultimately, what we're doing here is we're multiplying the fraction by 1. And we're allowed to multiply any fraction or any number by 1 because it doesn't change the value. It's only changing the look. So in the numerator, we have the square root of 3 times the square root of 2. In the denominator, we have square root of 2 times square root of 2, which is square root of 4, which is just 2. Your eyes are going to want to cancel those, but don't do that because it's not right. You can't do that. Radical 3 times radical 2. Now we're going to reverse the big idea from the last, basically the multiplication section. And when you see the radicals are the same, they have the same root, you get to combine what's under. 2 times 3, well, I'll write it like that, 3 times 2 over 2, which is 3 times 2 is 6. Well, we can't, there's no the pairs of factors in here underneath the radical, so we can't pull anything else out. We have to leave it alone. Radical 6 divided by 2 is it. That's it. So let's go on to the next one. See if you can do this one on your own. Pause the video, try it on your own. 16 over 12, so we're going to leave the 16 up there, we're going to leave the x to the 4th up there, and the 12x down here. Now we can cancel things right away here, and let's go ahead and do it this way so you can see it. This is a reminder of the last unit. We multiplied all these, we had rational expressions that we were simplifying, so we multiplied every prime factor. We prime factored every single thing so we could see 12 is 2 times 3, and then we have an x. So anytime we have the same factor on the numerator, in the numerator and denominator, we get to cancel because any number divided by itself is 1, and so we're just replacing those with 1, and 1 times anything is the anything, so we don't write the 1. Then we have an x, same factor up on top and bottom. So what do we have left in the numerator? Well, we're going to leave it factored. We have the square root of 2 times 2, and then we have x times x times x. And then downstairs we just are left with a 3. Well, we're going to reverse the big idea again, and we're going to rewrite the numerator as 2 times x times x times x. The denominator is just radical 3. And so let's do this all in one shot, meaning we're not going to simplify the numerator yet. We're going to wait. And we're going to multiply top and bottom of this fraction by radical 3. So we're rationalizing the denominator. And when you multiply the top by radical 3, they have the same root, so we get to pull that 3 inside the radical. 2 times 2 times 3, we're going to write them in order, x times x times x, all over radical 3 times radical 3, that's just 3. Now we finally have one last step here. We know we have the square root, so we're looking for pairs of factors when we have 2 of them. A pair of 2's means we could pull a 2 out. A pair of x's means we pull an x out. Underneath the square root symbol, we have a 3 and an x in there. And then all underneath the entire fraction in the denominator here, we have a 3. So 2x times the square root of 3x all over 3.